So good morning. Welcome to the Discover Greif webinar series. Thank you for the tremendous support that we have received from you regarding this series. Just to get us started, I'm going to put up a quick little poll here and ask how many of you have attended one of our previous webinars. If you could vote, you can vote for more than one if you've attended multiple ones, if this is your first one, or if you've been to others. So kind of nice to see how many people have been joining us. Give that one more second. We appreciate that during this time, while we're still not able to visit with you in person, that we actually have this opportunity to share with you about Greif and our products, and we hope that you will continue to find all of this as value. So I'm going to share the results. It looks like we have quite a few that this is your first webinar, so thank you for joining us and welcome to our event. I'm going to get started. Today, our focus is on plastic drums, and we're going to discuss our global plastics portfolio. My name is Cheryl Cottle, and I am responsible for marketing and communications for our rigid industrial packaging and services division. I'll be your moderator throughout today's event. If you attended the IBC webinar a few weeks ago, you'll be familiar with our presenters. With me today, I have two of our global product managers who are responsible for both IBCs and our plastic products. Luca Battoni, who is in Italy and responsible for EMEA and APAC, and Kevin Kling, who is in Ohio in the United States, who is responsible for the Americas region. Luca's background is in electronics and telecommunications, and he joined Fustiplast in 1999. He was in a sales role there where he focused on developing the Jerrycan business. From there, he increased his responsibilities for all other products, which included plastic drums and IBCs. In 2011, Greif acquired Fustiplast, and while at Greif, he's managed plastic sales in Italy and Germany. And then in 2016, his role expanded into product management. Kevin Kling began his career in logistics, working at C.H. Robinson. There, he was exposed to the world of industrial packaging by managing IBC collections. He made his way to Greif, and over the last 17 years, has served in various functions, including logistics, supply chain, procurement, and currently now in product development. So just a few housekeeping items before we get started. You will notice that we switched platforms to Zoom. I welcome your feedback regarding WebEx versus Zoom afterwards. If you would share that with us, we would appreciate that. But you'll notice that instead of a question mark, you'll find a chat button in the bottom where you can submit your questions to the panelists. Please feel free to do so throughout the presentation, and we've got a couple of opportunities scheduled to answer those questions for you. For those who are unable to attend, we are recording the webinar to share after the event. Our agenda for today will be as follows. We will review what is plastic packaging and how it's made. Pause after this first section to answer a few of your questions. We'll then review the diverse global portfolio of plastic products that Greif has to offer, and then we'll close again with some final Q&A. Thank you to our panelists. So I'll go ahead and pass the microphone over to Kevin, who is having a little bit of difficulties with his camera, so you'll notice that you're seeing equipment in place of Kevin's video today. But Kevin, I'll let you get started.
Thank you, Cheryl, and welcome everyone. Maybe you've wondered how our products are made or why so many drums are blue. Today, along with my colleague Luca, we're going to walk you through the kind of the basics and then get into a little bit more of the specifics on the products we produce. So first, let's start by defining the three basic types of packaging. We consider a drum a cylindrical container used for the transportation and storage of liquids in the case of a tight head, or powders or solid goods in the case of an open head. And while it's not an absolute, we consider a typical range to be between 10 and 77 gallons, or about 38 to 291 liters. Jerry cans we consider a rounded rectangular container. These originated as steel containers around World War II, and of course with the development of plastic packaging, it really opened up and expanded the capabilities of what a jerry can be. And they're typically used for storage of liquids, often contain one or more handles for ease of use, and they typically range from 5 to 20 liters. And the third are bottles. And we consider a bottle a narrow neck container used for the transportation and storage of liquids. And there's no really definition on size, but generally speaking, they can be very small and up to sizes like carboys you may see in brewing and other applications. Just the basics on the key raw materials. The first and the most critical is the resin. I assume many of you have a car, and over time you've probably had to fix something on the car. Could be new tires, problem with the engine, brakes. I suspect if we put up a poll and asked how many of you have ever had to fix your gas tank, very few would say yes. And the phenomena there is that your gas tank in your car and our drums are made with the exact same resin, which we define as a high molecular weight, high density polyethylene. And I think sometimes we underappreciate the strength of that material, but it's really what gives us the foundation for the drum. Then in the case of tight heads, we either have closures for drums which screw internally, or in the case of Jerrycans and bottles, typically we call them caps as they're screwing on externally. Then what we consider master batch is the colorant, or in the case of a natural drum, we put in a UV inhibitor to protect that polymer from degradation when stored out in sun. And this really gets into the question, so why are most drums blue? Well, the answer is pretty simple. When drums were developed around the 1960s, black was typically made from carbon black, which was non-FDA approved. And so between that and the fact that there was a lot of, regrind, recycled, typically was, the purity wasn't there. And then blue, on the other hand, it was a very low cost colorant that gave good polymer protection naturally. And so it just developed over, simplicity of why blue became the standard really in the industry. And it's continued to be that ever since. And then the last raw material we look at is if you have an open head is a cover and a locking band. When we get into the process later, we're really going to focus on showing how a tight head drum is made. But in the case of an open head drum, you typically have a secondary operation where you're cutting the top off, and then you're adding on the cover and lock band. Pass it over to Luca here.
Good. Thank you, Kevin. So you already mentioned about the colors and the fact that the majority of the plastic drums are blue, and that it is really covering, I would say, 80% of the total production of plastic drums. But blue is not the only color that we are using for producing our containers, and we are speaking about, in this case, also jerrycans, drums, and bottles. So blue, black, white, and natural are the most standard, the four standards for the industries that we are serving. But we are producing many other colors, because now there is the need for customers to have maybe their brand also visual as the color of the drum, and we are producing around 8 more colors than the 4 standards. This is really to cover any customer needs, and then to follow their demand to be really special and unique and recognizable among others. So this is what we are able to do without any limitation, and in all sizes. Obviously, the drums can be also tailored in other ways. So you can have some special customs labels available that are really branding the drums, and this is as an alternative, a lower cost alternative to the silk screening. So you can also count on this special tailor request. And then regarding the closures, there are many closures, and the closures are available with vent, without vent, tamper evident seal, so, and different type of necks and different type of connection depending about the need of the drums. The closure can be, as I said, vented because there are 2 typical effects on plastic products. So there is the need for a vent out, and the vent out is to relieve internal pressure about the product, because there are cases where there is a gas which is created by the chemicals or the product filled on drums. And then when there is a different and deviation in temperature, and then when there is an increase of temperature inside, so especially under the sun. And why venting? The venting is for the other way around, so to relieve external pressure. So there are some solvents which are need of air from outside, or where you have a different in temperature when you are feeling hot feeling And then when you are cooling down the product, if you are closing it, there is the risk of implosion, and this is avoiding this type of effect. And then also wide the vent during the use, because especially with the small packaging like jerrycans and bottles, which are usually used by hand, you need to have something to have a flow very smooth during the emptying. And this is why we have special inserts in our neck in order to avoid the product to have the glue effect and the waste of product as well. So we have a special type of closures as well in terms of sealings and different type of necks, because we have the internal plastic plugs with different type of thread, NPS, NPT, buttress, and 56x4, or the typical for jerrycans, the external screw caps, which are 45, 50, 60, and 63 millimeters. So all the necks which are available in the market or needed in the market are available in our portfolio of products. So I hand over now to Kevin again for further details.
Thanks, Luca. You know, one of the most common we see here is hot filling applications. So that vent in, oftentimes when when there's a problem with the packaging or customers having issues, that typically is it, where we see a hot fill application not allowing the package to cool, and then putting the closures on and putting them in stacks. So various needs, but that would be the most common that we see. Now we want to talk about the types of molding processes, as it really pertains to industrial packaging. And the first is blow molding, and we consider blow molding a process where we make hollow products. And really the key to blow molding is the air. So the air is used to inflate a plastic tube and really push it out against the mold. And we're going to show this in a little more depth later. And this is really the process in where we're making our drums and jerry cans and bottles. The second process is injection molding. Injection molding is where we're making solid products. And contrary to blow molding, air is the enemy here. So if you get an air pocket in the product while you're molding it, that's going to ultimately create a brittle or a weak part in it. And common parts that we're injection molding would be caps, closures, plastic locking bands, and plastic covers. And then the third process is extrusion molding. Extrusion molding is used to produce tubular products. And basically plastic is forced through a die, and then as it cools, it can be cut or printed on. The most common product you think of being extruded is a pipe. But when we talk about one of our products later, the Next Drum and Valorx drum, we really combine the extrusion molding with injection molding to kind of create a drum in a different format, which gives it some key advantages. Within blow molding, you've got your standard monolayer as well as a CoEx, and we define CoEx as a multi-layer application. And there's different reasons why you'd want to use CoEx. Back to our example on the fuel tank in your car, that is actually a 6-layer CoEx blow molded package. And the key there is they're adding in one of the layers for permeation to prevent the gasoline from traveling through the plastic to the outside. Another application, and one that Greif is very excited about, is using it with PCR, which we define as post-consumer resin, which really means when we're collecting drums and IBCs, and we know exactly what was last contained, that we're able to take and sub-select from that material, grind it up, and repurpose it back in the middle layer of a drum, and then we encapsulate it with virgin material. This allows us to, again, create a very nice sustainable story, and also prevent some of the traditional issues with using PCR, such as the smell. Another application is purity. So you may want a drum that has no colorant in the inner layer, and with a multi-layer technology, we can do this. And the last would be if you needed higher environmental stress crack resistance. For example, you could get the strength of the drum grade material, but use an IBC resin in that inner layer. So over the next 4 slides, Luke and I are going to walk you through sort of a cartoonish look at the actual blow molding process. And the reason we want to do this is after that, we're going to show a video of the process from molding through the quality checks. And one of the limitations you'll see is a lot of the process when the mold closes, you really can't see what's going on. So this just gives us a quick opportunity to first show you so you kind of know what you're looking at. The process starts as the resin and the master batch are heated and mixed together in the screw, and then they're forced through a die, coming down what we call the parison. The parison goes over the blow pins, and then the blow pin gives a pre-blow in order to help spread the material in the key areas we want, right? We're not making a ball, we're trying to make a cylindrical drum. In order to do that, you've got to force material into certain key areas in order to keep the weight of the drum down and get the shape that we desire. At this point, we've got the top ring slider comes in, and we're going to continue to add more air, and we're going to start to blow with the shape that you know as a drum. Now the key at this point, one thing you may notice is the drums are produced upside down. Second, in the blow pin, in the case of an open head, you'll have one center blow pin. In this case, we are making a tight head drum. And so while you can't see it, picture that there's one blow pin behind the one you see. And that's going to be two purpose. One is going to help to blow the air into the drum and expand it. And secondly, that's how we form the threads for the closures. So in the end, it's going to end up unscrewing. At this point, we're going to close the compression ring, and we're going to form that top chime. And at this point, the drum is essentially the shape you want it to be. Now there's different processes. Some machines are continuous extrusion, some are accumulator heads. And so there's some subtle differences in the process at this point. In this example, the mold is going to be indexed to the side and to allow the cooling process to occur. In other applications, it may stay in place before the next drum is started. So we start to reverse the process. We're trying to exchange the hot air in the drum with cold air. At the same time, we are circulating chilled water through the mold, as everything is about trying to take it from 400 plus degrees down to ambient. The quicker you can do it, the faster the cycle time. The blow pin now gets unscrewed, forming those threads and making sure that we don't compromise them. Then we're going to start to open up the top slider. And at this point, you'll notice that the flash on top is handled by a gripper. In the case of automation, you may automatically deflash it. When we show the video of the drum, you will see this process. In other applications, the drum just may get dropped at this point, and you've got an employee taking the drum and manually deflashing it. It just depends on the product and the application. Mold opens, and then basically we start the process over again. So that's the basic process. Now Luke is going to take you through two parts. One is the inline testing that we're going to do once that drum comes off the line, and the second part is going to be just talking about the periodic standard UN testing.
Yeah, thank you, Kevin. Yeah, once produced, our product is now time to check and to be sure that everything is what our customer desires to receive. And first of all, we are checking 100% of our product before to be shipped to our customers. And we have different type of tests that we do in every single piece that we are delivering to them. And for sure, those type of tests are not disruptive tests, so are just a checking test. So we are measuring the weight of the product, because this is very important because we want to be sure that every single piece is the right weight that needs to resist to make the mechanical performances of the usage of our customers. And then every single piece is also tested at the leak test. We have an internal pressure, and we are measuring the pressure differential in order to check if there are micro leakages also, and to avoid leakages from your product, and in order to be sure for you to fill and to ship without any risk of losses of your product. And then we have also a visual check, which is very important, by the way, because in this case, we need to see if there are no deflashes, which are still linked to the drum, that can create some problem, especially in putting the cap seal on the neck, for example. And then if there are no discoloration of the drum, in order to have a visual effect which is in line with the expectations of our customers. And then if there are no distortions or visual effects on the surface of the product. So this is really for checking that what you are receiving is exactly in line with your expectation and what you need to do with our packaging. Then is a different what we are doing with the UN test. The UN tests are basically disruptive tests. So in order to check if the performances that has been considered as ideal for the drums that or jerrycans that we are delivering to our customers are indeed in line with the performances that we need to achieve. There are different type of UN approval levels. So first of all, what is produced in plastics is identified with an H, and then, for example, a tight head drum is identified like 1H1, or an open head drum is identified as 2H1 or 1H2. So depending on the type of product. There are different level of UN test based on the packing group of the product that must be filled. So the packing group 1 is linked to an X UN approval, which is the highest level. And then the packing group 2 is a Y, and is the medium level. And then the packing group 3 is a Z level. So all of our products are basically tested for packing group 1 and packing group 2, including the packing group 3. So one of the tests is the hydrostatic pressure test, because we want to put a blow, and we blow the product in a pressure, and the product must resist in a pressure which is almost 1 bar for around 30 minutes without any leakage of water which is contained on it. And then we are running the stack test in order to see the ability of the drum to resist to a weight, because most of our products are designed to be stacked during the transport with the product on it. And then we need to resist for 28 days or 40 degrees in this stacking condition, and measuring the weight that we need to resist. Obviously, the weight is linked to the type of size and the weight that must be supported. So different is 1 liter to the 220 liter packaging. The drop test is then the final one, because it's a very strong and disruptive test. So usually the plastic is conditioned to a very critical temperature, so at minus 18 degrees Celsius, in order to bring the polyethylene in at the level of the maximum critical condition. And then with a glycol on it, so a liquid that remains a liquid also after the conditioning at such low temperature. And then this, the product must fall from a different height depending on the packing group that you need to achieve in terms of UN approvals. But consider that, for example, for a packing group 1, we need to resist to a drop test even close to 1.8 meters. So this is absolutely a very, very strong test. And this is valid for all type of packaging, including IBCs, by the way. And then also there is a different angles that must be considered for the drop test. The final point is that most of those tests are made usually during the test with water or glycol, like the drop test. But before, the packagings are conditioned with the 5 standard lipids, because in order to check the chemical compatibility also of our product with what our customer needs to fill, we are considering the conditioning, and then the plastic must resist to those tests also after a certain time of conditioning, where those chemicals has the time to attack, or in theory, create issues on polyethylene. We need to resist also in this case. Those 5 standard lipids, I would say, they are covering 80% of the total chemical product. And then for some products which are not linked to standard lipids, we are running specific UN approval depending on specific liquids, in order to be sure that we are covering also other products which are not linked to what are called the assimilation products. So you can ask and reach out to us in case of special needs, and then you can also ask at every time at your account sales manager also the indication about the assimilation between your product and the packaging that you would like to use. I will hand over now to Kevin for this movie showing in reality what we are doing in line with our process.
Oh, thanks, Luca. Again, we wanted to share with you, Greif invested last year in 2 new state-of-the-art 3-layer Caltex blow molders. And here we're showing one of those blow molders in process. This is still at Caltex with full automation, but it gives a really good depiction of the process as you can see the drum made. So here's a better visual. You can see the 2 blow pins. We'll see the Parison come down, and then you kind of see the process with the stretch, the pre-blow. The top slider ring is now going to go up, and we're going to start forming the drum. All the hoses around are for the chilled water, again, for the cooling process as we're trying to work on and improve cycle times constantly in order to maximize throughput. In this case, we do have the full automation, which is a trend we think will continue to advance, particularly with COVID and the need to distance workers. So if you can do it with automation and no employees, that much better. So there we've just removed the top flash. And one interesting aspect of drums that not everyone's aware of, your standard drum has about 20% of internal flash that we've regrind and put back in the process. And when we test drums, a drum is typically stronger with a small amount of regrind, again, internal regrind in it than if we were to use 100% virgin material. Here in the process, you're seeing the drum indexed into what we call PMC, or post-mold cooling. Post-mold cooling is a process to control the shrink of the drum after the manufacturing process. At the same time, we can also check for any leaks. From there, the drum's going on to get the weep hole punch. And again, this is in case the drum is stored outside in order to allow rainwater to drain off the top of the drum. Now we're doing the weight check. And then here we've got a final evaluation. You will notice they're still at the end of the line. We haven't figured a way out to get out of the still having a human being do the visual inspections that Luca mentioned. Again, making sure that the flash and everything else was as expected.
Kevin, we have one quick question. They just want to know if this process is identical in all of our plants around the world.
It's a good question. I would say the process is similar. The checks are all there. Different applications have slightly different equipment, and so it wouldn't be a mirror image from one to the other, but the concepts would be the same.
Yeah, also the technology here is evolving also in the blow molding. So every producer is now also offering to Greif improved technologies. And then when we are investing, like the machine that Kevin just showed, this is the latest state of the art. And then another machine in another country, which has been installed, I don't know, 3 years ago, is slightly different, but the concept is, Kevin said, absolutely similar.
No. Thanks, Luca.
And then one last question before you get into the product portfolio. What's the resin feedstock for HDP?
The resin and feedstock. So the resin is high density polyethylene. With that being said, the main feedstock is ethylene. And so, a lot of times if you're trying to understand the, what is the cost of the manufacturers, ethylene is often the #1 tracked, raw material. With that, of course, there's a correlation to natural gas and oil, depending on the region. North America is deriving more of their ethylene from natural gas, whereas, say, China is dominantly coal, and other areas may be more oil-based. So now we're going to talk about the products. Just a quick snapshot of Greif globally. We are the 2nd largest manufacturer of plastic drums in the world. We currently have 24 manufacturing locations. We are the largest open head drum producer, and ours range from 8 to 77 gallons, or roughly 30 to 291 liters. We have a lot of very unique designs that we've designed specifically to tackle customer problems. We're not going to go into all of those today. Some of them are very niche specific, but we just want to share with you that if you have any challenges or you're looking for a developmental partner, we love to be part of that process, and we think that is where we shine. In addition, we'll talk a little about the next drum and the Valorx drum, which is more of that extrusion injection molding process versus traditional blow molding. And then we are also a significant player in producing jerry cans and bottles, which range from sizes from 1 liter up to 30 liters. Here's just a quick look at our footprint. Right now we have just over 100 blow molders, not including what we use for IBC. And we vary from region to region. And again, it comes back to where we have a need by a customer. We will put in a production site in order to support you. So now we're going to talk about the tight head plastic drums. When the drums were developed in the 60s, some of the key features for them were they were lighter than steel drums, and they were really easier to handle. And some of the keys to that were because they didn't rust, dent, or peel, as well as they're inert to extreme pHs for products like acids. And they continue to be seen expanded as they can be cleaned, reconditioned, and repelletized, and ultimately being used back in the process, including some products we'll talk about in a little bit. The GP, or General Purpose Series, has 6 main sizes. And the key to these drums, they typically have a large molded ring at the top. We often refer to that as a chime. Some of you may know it as the L ring, which was kind of the industry standard design originally produced. In addition, they've got a sump well in the bottom, and in between the rolling hoops on the side and the top, there's protected area for putting labeling. Similarly, we have the Plastic Keg series, and these range from 8 to 20 gallons in North America, and then 50 up to 120 liters in Europe. The use is the same. The one difference is with the smaller sizes, we commonly have either a molded in handle or an exterior handle that we've put on top of the drum, and to make it easier to maneuver and use. So now we talk about the next drum. This is the drum that we extrude like a pipe, and then we injection mold the top and bottom. The key advantages to this is the process is a lot more precise. If a standard drum is 20 pounds, the next drum is around 18 pounds, but has significantly increased performance. On the open head version of the next drum, we have stacked up to 10,000 pounds, which compared to a standard 4,000 to 5,000 in a typical drum. So again, performance is significant. It does have a foot ring, so stability, particularly on automatic fill lines, conveyors, is better. And because the walls are so smooth, it resists chemical stress cracking much better than standard blow molded drums. Switching from tight heads, right, which we mentioned earlier is commonly liquids, to open heads, think of more powders and solids. We've got quite a diverse portfolio. One thing I want to point out is, as Greif grew through acquisition, we have some different series of drums. We have the POH, which is our plastic open head, OS, which just stood for open head straight sided, and OK, which still makes me laugh today. It just stands for an OK drum. Really, the concept's the same of these ones. They're there for, you need an open head drum, you want to be able to stack. And then it just really comes down to what size do you need. In addition, we have the open head 55-gallon foot ring drum, and this is the #1 open head drum sold in North America. And then define the standard logic of solids going in open heads. We also have the LR35, which is a liquid rated 35-gallon drum. We also have a tapered version of a liquid rated 30-gallon drum, and we're in the process of developing the open head 55-gallon foot ring drum for a UN rating with liquids. Within all these drums, you've got various options for covers and lock bands. Could be steel, could be metal, could be bolt ring. And some you want flat covers, others are bung and vent. So it just comes down to customization and what customer needs.
Yeah, thank you, Kevin. This is the portfolio of the open head drums in Europe, because just a very quick point, the tight head drum is absolutely identical in Europe, North America, or Asia, because it became a standard. So the 220 of the 55 gallons tight head is almost the same. Different is the shape of the open-head drums. The open-head drums for historical reasons are made in a different shape in Europe, which is more rounded. And we as Greif, we are producing basically all the sizes that are required in the market. So we are starting from a very small drum, which is close to 6 liters, and we go to 28, 30, 60, 150, and the 220 open-head drums. So the small drums are obviously available with the lateral handles, because they can be moved by hand by operators. So 30 liters by 1 operator, or the 60 liter by 2 operators. So that's why 2 handles. And then the 120 liter is available in the round shape, or we have also this special square shape, which has been designed in order to fulfill perfectly the ISO container, and then to increase the quantity of your product, then can be shipped in a container in those type of open-head drums. So this is improving the quantity from 108 to 144 open-head drums, basically with the same size, but with the best and the perfect occupation by the space. There is also the opportunity to have in the lid some small opening for customers which are intending to fill with liquids. And we have the opportunity to have UN approved drums for liquids also in the open-head version. And this is available in the size of the 120 liters. And this is a special drum with a heavier body, heavier ring, and a heavier lid, able to resist to the hydraulic pressure test that we have seen before. Because if not, the open-head drum, as Kevin said, are mainly used for powder or solids product. Also in this case, you can count on different colors. So the standard is also here, the blue, but you can have it available in different colors depending on your needs. So this is really the standards in Europe. In Latin America, this is a very quick update about one of the latest developments that we have achieved. This is a drum which is also been designed in order to increase and to reduce the space of occupation about those drums, and to reduce the weight of the drums and resisting to the same performances. So basically with this square or semi-square design, we have been able to reduce the weight of the drums anyway, fulfilling the mechanical performances which are required for stacking 1+1 the drum in ISO container. And this is really optimized for the pallet footprint. So you can reach out to us for any type of specific desire for this type of drum. So I will hand over now to Kevin for the Tapered and MB series.
Thanks, Luca. So the key advantage to tapered drums over straight-sided is the ability to ship significantly more drums in the trailer and save on freight costs. The most common applications we see are in food. We have customers, for example, that are packaging peanut butter, might send it to a company that makes ice cream. That customer wants to make a peanut butter chocolate ice cream, and so they empty the drum. They then restack the drums, not a whole lot different than a traditional sleeve of coffee cups. And then they send it back to the peanut butter producer to wash them out and reuse them. And so we've got a wide array from 14-inch to 23-inch diameter, up to 55 gallons. And so the traditional taper design was meant for this. One limitation with that taper design you see in the upper right is often in transportation, the lock band of one drum would get under another and pop the lock band and cover off. For this purpose, we developed the MB, which stands for Mega Bump series. That's the drum you see there in the lower left. And the bump on that actually sticks out wider than the lock band, preventing the ability for the lock bands to sort of connect and knock one or the other off.
Yeah, we talked about a lot about drums, but there are no only drums in our product portfolio, and Greif has a clear strategy to become a very big player in the Jerrycan business. And that's why, in order to achieve this strategy, we have also developed a specific Jerrycans in order to be successful in the market. And the Jerrycan is what is called JCR, so our Jerrycan reinforced. Basically, we have developed these jerrycans in order to be produced globally, identically in every plant where we are producing jerrycans within Greif, in order to offer our global customers to have identical product in every country where they need to have it. JCR is basically has started as a project for the 20 and 25 liters, which is now installed in Israel, Sweden, Singapore, and Italy. And basically with this project, we have been able to develop a jerrycans, which is basically occupying the same dimension. So it's not different compared to the ones that you are using in your filling lines, but is able to resist more with a lower weight. So basically we can achieve the traditional performances, reducing by 10 to 12% the total weight of the packaging, thanks to special reinforcement in the profile of our jerrycans, both in the corners, but also in the top and the bottom. So everything is studied to resist more using less quantity of polyethylene. We are now implementing it in Latin America, and also now the 5, 6, 10, and 12 liters will be followed in order to have the complete range from 5 to 25 with the same family. So this is, as I said, an innovative product for reducing the total consumption of plastics. You can have it available in monolayer or multi-layer technology, including the option to have the permeation barrier. And this is both in the traditional CoEx technology or with what is called our shield technology. So another brand of different product in order to achieve the same barrier performances. We have, as we said before, anti-glue system directly in the neck, and the closure can be with different sizes, different type of necks, different type of threads, with and without venting. So fine. The final point is that JCR is also available with the PCR, so recycled polyethylene, what is called the post-consumer resins, in order to achieve sustainable goals for us and for our customers, and be in line with what is the EcoBalance product line of our product. So again, JCR is our standard globally, which is now growing more and more year over year. On top of this, we have a specific family which is available in multiple countries of our footprint, which are the Agro Bottles, because we believe that this business is an important business for us, and we want to follow also this growth in this business. There are special requirements here, especially in the barrier effect. And basically the two standards or the three standards which are available in this market are the 20 liters that we have already seen in the JCR series, but there is also the 5 liters, the Agro Light. So it's an innovative and sustainable packaging, with also here the trend to reduce the overall weight of plastics, and then totally compatible with the C95 filling lines, which are the typical for the agro business. Another important size for Greif is the production of 1 liter bottles. And in this case, bottles which are the ring bottles or flat bottles are really sustainable bottles, also in this case, with the aim and the goal to reduce the consumption of plastics in order to reduce in every bottles that we are producing the CO2 emissions, which are multiplied by millions and millions of pieces that we do every year. As I said, well, there is, as you can see probably all around of us, a very negative campaign around plastics, but the reality is absolutely not what probably we are listening in our media. Today, over 20% of drums and jerrycans are reconditioned and reused, because polyethylene has the very big strength that can be regrinded many times without losing the mechanical performances. So the point is really to create a virtual loop, a virtual system enabled to work together in order to increase this percentage, because the problem is not the plastic. The problem is that we are not collecting enough because we don't have a system ready to reuse or collect immediately polyethylene. Greif is investing a lot in this sense. we have created a special lines of product which are called Eco Balance, where we are producing our packaging with a percentage of post-consumer resins, recycled polyethylene, which is coming from the collection of empty packaging. So basically, it's also called the post-industrial resin because we are collecting industrial packaging. We can achieve in a monolayer or multi-layer technology a percentage up to 75% of PCR in this case. We can do it with and without UN approval, depending on the product that our customers are filling. And in this case, we can guarantee the CoEx also the opportunity to have the inner layer, which is in contact with the field product with virgin resins. And the PCR only in contact with the external layers. So we can do it in 220 liter series, both open head and tight head with a foot ring. And also in this case, the percentage in the open head can be 60 and 50% of PCR. And then we have also the opportunity to have it introduced in other type of packaging and other sizes. So, for example, this is something that we are doing in North America, the 55 gallons. This slide is showing what we are doing also in Europe. And basically, we do it since more than 20 years. And we can do it in jerrycans, we can do it in drums. And probably for the one of you that have seen also the webinar on IBC, we have also started producing IBCs with the plastic bottle with 60% of the total weight made by PCR, also in the transparent color. The point is that today, because we are doing since many, many years, we are producing more than 1 million of our jerrycans and drums with the usage of PCR. The point is that we can be more successful if our customers can help us to collect more. So that's really something that we would like you to be in contact with us in order to create a very virtual system in order to collect more. More we can collect, less new resources we can use in the next years.
Thanks, Luca. No, that's great. Really, the last point we want to touch on today is just cleanliness and food safety. We've got some specialty products where we are using clean rooms. We call them the DP20, DP60. It's really a hybrid between a drum and a pail. And we pretty specific applications, but we are also looking at some step changes in the process in order to produce, say, for example, 220 liter, 55 gallon drums in very high purity applications. We're also very focused in the food segment. We have several plastic plants, not to mention Fibre and other plants as well, that are SQF certified. And this is really part of the Global Food and Safety Initiative. Just again, trying to ensure that we meet those needs above and beyond the standards which are set today in the industry. And then just one project we wanted to highlight around this is we are adding a new plastic drum line in Durban, South Africa. And again, the key here is we're focused on a food certified facility, which will be in production later this year. And they're producing 210 up to 250 liter drums. And they're focusing on the double ring shape, which again, the double L ring focuses on, we talked about the L ring is the chime in the top. So the double L ring refers to having a foot ring, much similar to when we talked about the Valorix and the next drum earlier. So just excited about this, wanted to share it. As mentioned, we continue to invest and grow where customers need us to, and we always love to get your feedback. So why choose Greif? Well, again, we're number one, we have the most diverse portfolio. Number two, we have solutions to meet sustainability goals. And we truly think this is where the future is going for packaging. As Luca mentioned, plastic right now has a bad reputation. And so in order to preserve this, we really have to become stewards of the industry and ensure that we are finding ways and challenging ourselves to repurpose and to recycle. Customization, you saw a lot of different packaging sizes, range, types. For us, that's the most fun part of the job. You've got a challenge and we get to tackle it. global security supply, with our 100 blow molders around the world. We truly have packaging, and particularly now that we're focusing on things like the Jerrycan reinforced, where we've got standards and design. And then again, we've got a passion for focus on cleanliness and food safety. So again, we're humbled to have you as customers or potential customers, for those that we're not working with today. And we thank you for joining us.
Thanks, everybody. So we have a few questions for you guys, Kevin and Luca. You guys have such a wealth of knowledge and information. We're really fortunate to have you on our Greif team. One of the first questions was, will this presentation be sent out to viewers? So I do want to just let you know, yes, we've recorded it. We'll share the recording, and we will have your account managers, we'll have the presentation available to share with you as well. So one question is the Nextrum and Valerix the same? If not, what's the difference?
That's a good question. They are not exactly the same. The Valerix is truly straight-sided. The Nextrum has a little bit different toppering, which was developed later as sort of a output of the Valerix to make the handling more in line with a standard plastic drum.
Great. And one question here was about the height difference from the blow molded drum.
The Nextrum versus blow molded? I'm assuming it's the Nextrum versus the blow molded drum. They are different. So very subtly, you've got a 55-gallon drum, which is North American dominant. The rest of the world, I'd call it equivalent size, is a 220 liter. They're close, but not exact dimensionally. A 220 liter is typically slightly narrower and slightly taller. The reason I do this is it meets the ISO dimension so that you could put them 4 wide in a standard ISO container for export, as opposed to 3 wide of typical drums. Now there's people out there that squeeze these drums in and find a way to get a 55-gallon 4 wide, but it's not typical to what expected. When Greif developed the Nextrum, we made it so it met more in line with the 220 liter ISO dimensional, so you didn't have to have 2 different drums, one for domestic and one for international.
Someone asked, where does the term Jerrycan originate?
Oh, that's a good point. I really trying to find also this nice name also in my knowledge, but really wasn't able to find the right origin of this. I don't know if Kevin, if you have another experience, honestly, but this is very, very fun.
I can't give you 100% the fact right answer, but it comes down to the war. I think it was World War II. And I can't remember if it was, again, potentially Germany had developed the Jerrycan, and then others had started to saw it and were fascinated and thought that it was a great design, so they wanted to start producing them. And then it became some name which they associated with the with one enemy or the other, and it was kind of a nickname that was given, and it ultimately became just known as the Jerrycan. So I know if you're really curious, put Jerrycan in Wikipedia. They've got the exact story there. And hopefully part of what I said somewhat lines with it.
Yeah, I think it fits on the back of a Jeep or something like that, right? I think I've read something along that. There's like a certain little spot for it to fit onto. Right. Let's see, we've got some other questions about EX-proof Jerrycans or drums with food approval. Are there any options for that?
So in this moment, we are producing, for example, in Italy, some 5 liters jerrycans, which are AX and food approved. This is a very special need by a customer, and this can be enlarged to any type of packaging, just depending on the customer needs. So for one customer that wanted to have it, we did it, because the additive that is now used for producing AX product is also food approved. There is also a point to be taken in consideration, because when you are producing over 5 liters, you need to have something within the packaging in order to conduct externally the AX, so the electrostatic charges. And in this case, we need to be sure that also this type of inserts are also food approved. But you can reach out to me, and we can develop, or we can go in details about this existing 5 liters in order to share the technical details.
Perfect, thank you. Let's see, a couple other questions with regard to recycling and reconditioning. So one person wanted to compare them to a steel drum, like what's the environmental footprint? I think there's more to that story than just compare one to one, and you offer the green tool, which allows you to do a full comparison, like how far you're shipping your product, in addition to the recycling component. So I think what we can do there is have someone reach out to you about our green tool options. But then someone wants to know, what about collection facilities in North America? Are we reconditioning anything here?
Yeah, so for collections in North America, one of the short-term challenges in industry is there is a glut of recycled material currently. And so it's changed some of the dynamics of the collection process and the minimums. Right now, Greif does have a program in place for collections. And so again, we've got that, we've expanded it. We've partnered with a company called Centurion in order to really focus on the expansion of our collection of plastic drums and IBCs. And so we're very interested. If you have those, again, we can have somebody follow up and reach out. We continue to work on it globally. You know, some areas are more challenging than others, but obviously one of the key takeaways from this, as you see, a lot of our development work right now is how to repurpose that material. And so that we're really looking at that as a raw material. So it's in our advantage to be able to collect, bring that back and reuse it. So we're definitely excited about that. And again, if there's more specific questions, you know, we can reach out and provide more specifics around it. But thank you.
Thank you. I know we didn't get to all of the questions there, but we will follow up with everyone afterwards, and we will share, again, the recording with everybody. So before I wrap up today, I want to launch one more polling question, which is really just simple. You know, we've covered a lot of topics today, and we want to know if you would like a Greif representative to contact you regarding your plastic packaging. So you can go ahead and vote right there and let us know, and we'll have someone reach out to you after this is over and discuss some more of our options with you. And then one last note as we're collecting those responses, Kevin, if you could flip to the last slide. Our next webinar will be next week. We'll be covering our fiber drum portfolio, and we'll be hosting that on Thursday at this same time. So be on the lookout for the registration to attend. I also welcome again your feedback regarding Zoom versus WebEx, so feel free to reach out to me and let me know if you found that of value or not. And we just want to thank you for attending today, and have a wonderful day wherever you may be in the world. Have a great day. Thanks.
Thank you very much. Bye.
Thanks, everyone.